and then you press down. So this is it's an angle of 83. Uh, I'm not sure about that, but 5 and 9 shouldn't
I
be
think I think there's an error or something.
degrees. Can you just retry that last time? I will take my calculator.
So like 5 divided by 9 inverted 10. Yeah, it gives me the same thing.
Maybe
Probably something wrong.
okay. Just try last time. 5 divided by 9, then equal, and then invert 10. Yeah, that's it.
Yeah, I have the same problems at school. I was doing my exam, then I'm like, what? Why isn't this giving me the right number? Like my teacher like, oh, you have to press equal first.
Yeah, but at least you how do you say that? Notice? No.
Noticed?
Yeah, you noticed it. My
At
students.
least you noticed. Is
Yeah,
that what you wanted to
yeah,
say?
exactly. Because my students usually don't, and then they just fail.
I'm used
And
to doing that when you do a moyenne.
yeah, oh yeah, and then you only divide the last number, like, and it's
Yeah.
okay. So anyway, we found that the angle right there was 29 dot I don't know what, but around 29.
Uh-huh.
So that's how we use that. Okay. Uh,
So basically, if we use this, it we're sort of gonna change the angle of the arm
exactly. You
every time
the mouse is
both
moving.
both of the play how do you say it, of those coordinates change,
Exactly.
or at least the one where the mouse is.
Yeah, because the other one won't change for now, except if we make the guy move with the keyboard, but maybe later. Okay, so for now we have to find the length of. Oh, just a second, my. I don't have, no, I have no more power in my tablet, so I will use my mouse. It's going to be okay. Mouse. Okay, so we have to find the length of this side and the length
Mm-hmm.
of this side. So what expression could represent the vertical one? This one.
um I kind of need kind of forgot what you wrote.
Okay, so just to remember you, this is the shoulder of the guy. Its coordinates are x s x x y, and this is the mouse, which has mx and my as coordinates.
Uh-huh.
So how can we? What algebraic expression could represent this side?
um
Oh, I know. I have a trick for you in math. When you don't know something, simply write
uh-huh.
simple numbers. Like, let's say that this is 1 and 2, and this is
Uh-huh.
4 and 6. So, what is the length of that side?
It's uh is it like domaine image sort of?
No, no, it's easier than that. Okay, if we are in a plan cartésien,
Uh-huh.
and this point is at 1 2, and this one at 4 6. How do we get from there to there? What's the length of this side?
Well, I'm stumped.
Okay.
I can't really remember.
Uh,
I'm sure I already did that, but I can't really
no,
remember.
no problem. How could I explain that to you? Okay. Let me a second. Where I have now. 6 minus 2. Okay, but why I was doing and just finish. What would be the length of this side?
If it's 4.
No, it's not 4 because it started at 1.
Oh,
No, sorry, it start at. Oh yeah, sorry, it's very 4. Uh, okay, so this one it's 6 minus 2 that which equal 4, and this one is 4 minus 1 which equal 3. You're okay with that?
uh-huh.
Okay, so my point was, if that is true, let's do the same thing, but instead of 4 and 6, we have mx, my, and we have sx, sy. So
Uh-huh.
what would be the algebraic expression that would represent this side here?
My minus sy.
Yeah, exactly. So my minus uh, sy, exactly.
I should have known that.
And here was what would be here?
Where?
Here, this side.
Um, would be mx minus xx.
Yeah, exactly. But minus, yeah. Okay, so that's my point. If when we have a triangle like before, like this one, and we want to know this angle, and this was 5 and this was 9, I told you that we had to do tan of 5 and of an angle worth 5 and 9, and then we do tan minus 1, so we have tan minus 1 of 5 on 9 equals the angle. So if we want the angle right there, we do the same thing. We do the opposite, so this on this, and we do tan minus 1 of that, and it would give you it will give us the answer, the angle.
So
So the
this is it's kind of like finding the A.
uh
Uh,
yeah, it could be the same. Yeah, because it's the this is delta y, this is delta x, in fact, and we do tan minus 1. The difference is we not simply do delta y and delta x. We are doing tan minus 1 of that to find the angle. So the final formula would be tan minus 1 of sy divided by mx. Anyway,
so I would have to before doing this, I would have to do uh this minus my minus sy, the and mx minus that. Then I divide it. Then I do 10 with the minus
yeah,
inverted
yeah, inverted tan.
uh uh by what the division gave us.
Okay, the division of this give us the slope of this line,
Uh-huh.
like you learned it this year. And by doing tan minus the inverted tan of that, we are getting
Gives you the angle.
the angle. Yeah, this is the angle. So this is the
So
angle.
uh-huh.
Okay, so let's go back in our code and we will type that. So first of all, we will create in the run function 3 variables. The first one will be delta y,
Whoops.
which will be a number equals something that we will write later. Then delta x,
X number bar.
and finally the angle.
So angle.
Angle. Yeah. Okay. So first of all, we were delta y. So delta y is a mouse like I write there, it is mouse y minus the shoulder uh, coordinate in
So
y.
I would write like mouse dot y minus
Yeah, it's
mouse dot x. I mean
the shoulder.
shoulder dot x or
Yeah, but
stickman
there
dot gun dot x maybe.
exactly that, exactly that. But there is an exception for mouse y. We have to write mouse with y in a single word with y in a capital letter, like that. Minus minus we want the coordinate of the shoulder, which is stickman.
Stickman
But in fact,
dot gun, I think.
yeah, dot gun dot y. But you have to understand something. If we only write that,
Mm-hmm.
this means the y coordinates of the gun inside the stickman object. But if we go in the stickman object, which is in the stickman object, I don't know if you can see if you look at the property of your gun, its coordinates are like 30 and 85, or yours are like
Minus 100, 144.
yeah, because that's because your stickman was not placed to the right of its little cross. Maybe you should unlock your layers
Uh-huh.
and select everything and then put that at 0 0. So this way your guy will be okay, perfect. And then you can lock down your stickman.
Okay.
Okay. So my point was simply okay. Click on the gun and look at the coordinates. Okay, get up, yeah, right there. Click on the gun.
Uh-huh.
Okay, we want the coordinates of the little cross on the left.
Uh-huh.
Uh, the one on the shoulder.
Uh-huh.
Okay, so right now those coordinates are 47 by
21.
121. Okay, okay, but if we leave the stickman by returning back to scene one,
Uh-huh.
the gun is inside the stickman. So the coordinates, the 47 by 121, are inside the stickman. But we want the global coordinates, the coordinates like on the scene. So what we have to do is to add the coordinates of the stickman, which are on your screen like 300 something. What are the coordinates of the stickman, like right now?
Uh 313 x and y
Okay,
198.65.
exactly.
So,
Those are
but
the coordinates of the little cross on the top left of your guy.
uh-huh.
And then we are going to add to this the coordinates of the gun inside the stickman. It's like I will just draw it right here so you can fully understand it. Okay, I have my guy. So those are the stickman coordinates. This and this, x and y of the stickman.
Mm-hmm.
But I want to go there. So I have to add this and this. I'm just going to um, so the first x and y are the coordinates of the stickman itself, and then we have to add the x and y of the gun inside the stickman.
Oh, so
How do we write that? It's simply like that. So it's going to be mouse.y minus the stickman.y minus the stickman.gun.y. Or maybe you can write it this way if you prefer, like in parentheses, mouse y minus the coordinate of the gun, which are stickman.y plus stickman.gun.y.